Welcome you all. In the last session we discussed the concepts of nested if and else if ladder. Okay. In this class we discussed some of the problems which can be solved by using else if ladder. Okay. One of the important problem is solving quadratic equation. Okay. This is one of the problem that can be solved by using else if ladder. So, the formula the equation for the quadratic equation is ax square plus bx plus c is equal to 0. Okay, the general form of quadratic equation is ax square plus bx plus c is equal to 0. This can be solved by using the formula minus b plus r minus square root of b square minus 4ac divided by 2a. This can be solved by using minus b plus r minus square root of b square minus 4ac divided by 2a. We can expand this equation formula into x1 is equal to minus b plus square root of b square minus 4ac divided by 2a. x2 is equal to minus b minus square root of b square minus 4ac divided by 2a. Okay, the quadratic equation ax square plus bx plus c is equal to 0. This can be written as x1, that means this can be solved by using the formula x1 is equal to minus b plus square root of b square minus 4ac divided by 2a. x2 is equal to minus b minus square root of b square minus 4ac divided by 2a. So, when you are solving this equation, there are three cases. Case 1 is bx square minus 4ac is equal to 0. 4b square minus 4ac is equal to 0. If the value of b square minus 4ac is equal to 0, then roots are equal. In this case, roots are equal. So, when the roots are equal, the value of x1 is equal to x2 is equal to minus b divided by 2a. So, when the value of b square minus 4ac is equal to 0, then the roots value x1 x2 is equal to minus b divided by 2a, Okay, that is a case 1. In the case 2 is if b square minus 4ac greater than 0. b square minus 4ac is greater than 0. In this case, roots are distinct. So, when the roots are distinct, the value of x1 and x2 means the root 1 is equal to minus b plus square root of b square minus 4ac divided by 2a. So, when the value of b square minus 4ac is greater than 0, then roots are equal. When the roots are distinct. So, in the case 2, if b square minus 4ac is greater than 0, in this case roots are distinct. So, x1 is equal to minus b plus square root of b square minus 4ac divided by 2a. Then x2 is equal to minus b minus square root of b square minus 4ac divided by 2a. x1 root 1 value is equal to minus b plus square root of b square minus 4ac divided by 2a. Then x2 is equal to minus b minus square root of b square minus 4ac divided by 2a. Okay, the case 2 is roots are distinct. The last case is case 3. In the case 3, if the value of b square minus 4ac less than 0, if b square minus 4ac is less than 0, then roots are real and complex. Real and complex. So, in this case, in the case 3, the root value x1 is equal to minus b divided by 2a, x2 is equal to sqrt square root of f abs float absolute of b square minus 4ac divided by 2a. Okay, x1 is equal to minus b divided by 2a, x2 is equal to square root of float absolute of b square minus 4ac divided by 2a. Okay, these are the three possible cases of quadratic equation. So, the case 1 is b square minus 4ac is equal to 0. In case 2, b square minus 4ac is greater than 0. In case 3, b square minus 4ac is less than 0. So, we need to check three conditions. Condition 1 is b square minus 4ac is equal to 0. Condition 2 is b square minus 4ac is greater than 0. And else b square minus 4ac less than 0. Okay, these are the three possible cases. So, here we need to use LC ladder to check this condition. Okay, now I'll write the algorithm for finding roots of quadratic equation. So, algorithm So, when we are finding the quadratic equation, we need to give three values, three inputs. Inputs is A, B and C. That is the coefficients. A, B, C are the coefficients, and output is root value, that is x1. I consider x1 and x2 are the root value. So, input is A, B, C and output is x1, x2, root 1 and root 2. So, first step 1 is start. Step 1 is start, then step 2. Step 2 is read values. Read values for A, B and C. So, read coefficients A, B and C. So, after reading the value, here we need to check one condition. The condition is the value of A, B, C must be positive number, must be non-zero value. If any one of the value is 0, then we cannot find the roots of quadratic equation. So, first we need to check whether the values of A, B, C is 0. If any one of the value is 0, then roots calculation is not possible. So, here we put one condition: if A is equal to 0 or B is equal to 0 or C is equal to 0. If this condition is true, then print calculation of roots is not possible. Okay, if this condition is true, then roots calculation is not possible. That is step the substep A. Then exit. Okay, if this condition is satisfied, print calculation of roots are not possible, then terminate from the algorithm. If in case if the condition is false, then step 4. So when we calculating the root, we check the value. The value is b square minus 4ac. In each step, we calculate b square minus 4ac. So here I'll consider DISC, discriminant. So first I calculate this value, b into b minus 4 into a into c. So before verifying the value, I will calculate the value of b square minus 4ac. So the value I'll consider as DEC, discriminant. So discriminant is equal to b into b minus 4 into a into c. So here I will calculate compute DISC is equal to b into b minus 4 into a into c. So first I calculate the value. So after calculating this value, next step 5 is check. First step is check. Here I will check if I have calculated value b square minus 4ac, the value stored in the variable DIC. So I will verify DISC is equal to 0. DI means the discriminant value is 0. If this condition is satisfied, then I will print roots are equal. So when the value of DEC is equal to 0, roots are equal, then the root value is b is equal to x1 is equal to x2 is equal to minus b divided by 2a. Now the root value is equal to x1 is equal to x2, x1 is equal to x2 is equal to minus b divided by 2a. So after calculating this value, print x1 and x2. So I will print the value of x1 and x2. Okay, that is substep C. If this condition is false, now the DISC is equal to 0 is false, then we need to check one more case. The case is step 6, else if DISC greater than 0. So here when this condition is satisfied, then roots are distinct. So print roots are distinct. When the roots are distinct, then the x1 value and x2 value is different. So, x1 value is equal to minus b plus square root of b square minus 4ac divided by 2a, and x2 is equal to minus b minus square root of b square minus 2a. So, here the value of x1 is equal to minus b plus square root of the b square I have calculated as ds disc divided by 2a. Then x2 is equal to minus b minus square root of disc divided by 2a. Okay, if the value of disc is greater than 0, roots are distinct, then x1 is equal to minus b plus square root of disc means b square minus 4ac divided by 2a. x2 is equal to minus b minus square root of disc divided by 2a. Then print x1 and x2. So, I will print the value of x1 and x2. Next, this condition is also false. If this condition is false, the remaining value is disc value is less than 0. So, here it is not 0, and if the value is less than 0, then if it is greater than 0, it will execute. If these conditions are false, the remaining case is the value is less than 0. So, step 7, that is else statement. Else, so print roots are complex, real and complex. Next, now here the value of x1 is equal to minus b divided by 2a, minus b divided by 2a. Next, b value is x2 is equal to sqrt of fabs of disc divided by 2a, disc divided by 2a. Then C, print x1 and x2. Print x1 and x2. So, the last step is step 8, stop. Last step is stop. So, for this problem, we need to read three values a, b, c are the coefficients. Output is x1 and x2. The value of x1 and x2 is depends upon the value of b square minus 4ac. So, b square minus 4ac is discriminant value. So, when you are calculating the x1 value, x2 value, we need to check three conditions. The three condition is, one condition is b square minus 4ac is equal to 0. Second condition, b square minus 4ac greater than 0, and remaining condition b square minus 4ac is less than 0. If the value of b square minus 4ac is 0, then roots are equal. In that case, the value of x1, x2 is equal to minus b divided by 2a. If condition is false, discriminant value is greater than 0, then x1 value and x2 value is, x value is minus b plus square root of b square minus 4ac divided by 2a. x2 is equal to minus b minus square root of b square minus 4ac divided by 2a. So, the case 2 is the roots are distinct. Then the last case is, if the value of b square minus 4ac is less than 0, then roots are complex. In that case, x1 is equal to minus b divided by 2a and x2 is equal to square root of float absolute of discriminant value divided by 2a. Okay, this is the algorithm for solving the quadratic equation. Okay, now I'll write the flowchart for quadratic equation. Flowchart for solving the quadratic equation. So in flowchart, the first symbol is start. Next, we need to read the values, that is input A, B and C. So after reading this value, we need to check the value of A, B, C. So if A is equal to 0 or B is equal to 0 or C is equal to 0. If this condition is true, then so here I'll write 1. So 1 means it moved to n. If this condition is false, then we need to compute the value, that is DISC is equal to B square minus 4AC. Here I will compute the value. DISC is equal to B square minus 4AC. So this 2 circle is the connectivity symbol. Here I am checking the value of DISC. If DISC is equal to 0. If DISC is equal to 0, if condition is true, then here I will print roots are equal, then x1 is equal to x2 is equal to minus b divided by 2a. Next, print x1 x2 if this condition is true. If this condition is false, we need to check the one more condition. The condition is if DISC greater than 0. If this condition is true, then print roots are distinct. So if roots are distinct, then x1 is equal to minus b plus square root of b square minus 4ac divided by 2a. x2 is equal to minus b minus square root of b square minus 4ac divided by 2a. Then print x1 and x2. I'll print the value of x1 and x2. If this condition is false, if this condition is false, so the remaining case is roots are complex. Print roots are complex. Then the value of x1 is equal to minus b divided by 2a. Then x2 is equal to square root of b square minus 4ac divided by 2a. Print x1 and x2. So here I will print the value of x1 and x2. So if any one of the condition matches, so we need to move to the control need to transfer to n. So after executing the corresponding statement, the control need to transfer to n. So here after executing case 1 it moved to n. After executing case 2 is also moved to n, and after executing case 3 is also moved to n. Okay, that is stop. Here there is one more control. If in case of the value of a is equal to 0, b is equal to 0 or c is equal to any one of the value 0, then it will terminate. So 1, it's also moved to n. It's also moved to the n. Okay, this is the flow diagram for finding or solving roots of quadratic equation. So start. After reading the values for a and b, we need to check if the value of a, b, c is 0 or not. If it is 0, terminate. If it is not 0, calculate the value. Calculate the discriminant value, that is b square minus 4ac. After finding the discriminant value, we need to check the 3 possible cases. Case 1 is DIS, discriminant value is 0, discriminant value greater than 0 and less than 0. If it is 0, roots are equal. So here x1 is equal to x2 is equal to minus b divided by 2a. If in case if the discriminant value is greater than 0, then x1 is equal to minus b plus square root of b square minus 4ac. x2 is equal to minus b minus square root of b square minus 4ac divided by 2a. Their roots are distinct. If this condition is not satisfied, then the remaining cases roots are complex. Here x1 is equal to minus b divided by 2a, x2 is equal to b square minus square root of b square minus 4ac divided by 2a. Then after exiting any one of the case, it will move to end of the statement. Okay, this is the flow chart for solving the quadratic equation. Now I'll write the program for solving the quadratic equation problem. So first I'll write the comment section. Program to solve quadratic equation. Program to solve quadratic equation. So in this program we need to calculate or we need to find the square root value. So in order to find square root value in C language, there is a mathematical function. The function is SQRT. So SQRT is a built-in function we use for finding the square root. So in order to use SQRT function in the program, we need to include the header file. The header file is #include math.h. So first I will include include math.h. Next, include stdio.h. Next is the stdio.h, then void main. Void main. Here, I already mentioned in this program 3 values are the input, means 3 values are the input, that is A, B, C. So, here all the values are of float type, float A, B and C. So, these 3 are the input variables. Output variables is x1 and x2 are the output variables. Then one more variable to calculate a discriminant value, that is dis is equal to 0.0. So, now I have declared A, B, C are the input variables, x1, x2 is the output variable and D is the intermediate variable for finding the discriminant value. Printf, enter the coefficient. So, means enter the value for A, B and C. So, scanf. Here all these 3 variables are of float type. So, the controls statement string will be %f, %f and %f. So, here we are reading 3 values. So, %f, %f, %f. So, address of A, address of B and address of C. So, the 3 values A, B, C. So, address of A, address of B and address of C. So, after reading this value, we need to check any one of the value is 0. So, if A is equal to 0 or B is equal to 0 or C is equal to 0. If any one of the value is 0, because here I am using logical OR. In logical OR, any one of the conditions true, the output is true. Means, if in case, if I enter the value of A is equal to 0 and the value of B is equal to -4, then here A is equal to 0, condition is true, and B is equal to 0 means B is equal to 4, condition is false. So, here true, false, it becomes true. So, then the condition is satisfied. So, any one of the variable value is 0, then this condition will be satisfied. So, if this condition is satisfied, printf print calculation of roots not possible. Roots not possible, then return. Return means it moved to end of the program. Okay. Here first I will check the values of A, B, C. If any one of the value is 0, it will display calculation of root is not possible and terminate. Next, if this condition is not satisfied, then DISC is equal to B into B minus 4 into A into C. So, here I am calculating the discriminant value. DIS is equal to B square minus 4AC. So, after calculating this value, here I will check the condition, that is roots are equal condition. If DISC is equal to 0, So, this condition is roots are equal. If this condition is satisfied, printf roots are equal. Roots are equal. If roots are equal, then the value of x1 is equal to x2 is equal to minus b divided by 2 into a, divided by 2 into a. Now the value of x1 x2 is equal to minus b divided by 2a. Then printf x1 is equal to percentage f slash n, x2 is equal to percentage f slash n, x1 comma x2, x1 comma x2. So here I will display the values of root 1 and root 2. If this condition is not satisfied, if this condition not satisfied, we need to check one more condition, else if DISC greater than 0. DISC greater than 0. If this condition is satisfied, printf roots are distinct. Roots are distinct. Then x1 is equal to minus b into minus b plus sqrt of DISC divided by 2 into a, divided by 2 into a. If this this is for x1 value. Next, x2 is equal to minus b minus sqrt DISC divided by 2 into a, divided by 2 into a. Next, I will print the value. Printf x1 is equal to percentage f slash n, x2 is equal to percentage f slash n, x1 comma x2, x1 comma x2. Now this condition also, if this condition also false, the remaining is else. Else printf roots are complex. Next, x1 is equal to minus b divided by 2 into a, minus b divided by 2 into a. x2 is equal to sqrt of float absolute of DISC divided by 2 into a, 2 into a. Printf first root is equal to percentage f plus I percentage f slash n comma x1 comma x2, x1 comma x2. Similarly, printf second root x1 is equal to percentage f minus I percentage f slash n comma x1 comma x2, x1 comma x2, then close bracket. So here it will display the first root value and the second root value, then it close the bracket. So this is end of if, this end of program. End of program. Okay, this is a program for finding. This is a program for solving the quadratic equation problem. So in this program, there are three inputs: a, b, c are the coefficients, x1, x2 are the roots, and di is the discriminant value, that is intermediate value. First we check the values of a, b, c. If the value of a, b is 0, then it will display roots calculation is not possible and terminate. If in case if the values are greater than 0, then it will check three cases. That is, case 1 is discriminant value is 0, second case discriminant value greater than 0, and third condition discriminant value is less than 0. So case 1 is roots are equal, case 2 is roots are distinct, and case 3 is roots are complex. Okay. Now execute this program. Just now I explained the process of solving the quadratic equation problem. So I have explained algorithm, flowchart along with the code. Okay. Now I am demonstrating the solving problem of quadratic equation. Here is a program. I have defined three variables a, b, c. I already mentioned. A, b, c are the input variable. X1, x2 are the roots, and d is a discriminant value d, and r and I is the real and imaginary value assignment. So in this program there are three inputs: a, b, c are the coefficients. Then before calculating the discriminant value, we are checking whether the values are valid input or not. If any one of the value is 0, then the calculation of the root is not possible. So here we are checking a is equal to 0, b is equal to 0, c is equal to 0. If any one of the condition is any one of the value is 0, then the program will be terminated. So it will display invalid input. After that, we calculate the value b square minus 4ac, that is b into b minus 4 into a into c. So in the quadratic equation problem, there are three cases. Case 1 equal to 0, case 2 greater than 0, less than 0. First here I am checking greater than 0. Greater than 0 means roots are real and distinct. So here f x1 is equal to minus b plus square root of d minus d divided by 2a. Similarly, x2 minus b minus square root of d divided by 2 into a. After that, we check one more condition. One more condition is d is equal to 0. If d is equal to 0, then roots are real and equal. If this condition also false, the last condition is real and imaginary. Okay. This is the program for finding the roots of quadratic equation. Okay. Now I'll run this program. Okay. My first input is 1, 2, 1. So when you give this input, the discriminant value will be 0, then roots are equal. Okay, here it display roots are real and equal because the value of x1 is equal to minus 1.0 and x2 is also minus 1.0. Similarly, I'll check one more condition. Okay, here I'll give 1, 4 and 1, 1, 4 and 1. So when you give this number, Now the value is the roots are real and distinct. X value is equal to minus 0 dot 267949 and x2 is equal to minus 3 dot 732051. Okay. For the value 141, the roots are real and distinct. Roots are real and distinct. Okay. There is one more condition, that is the roots value is less than, means a discount value is less than 0. 1, I will give 2 and 3. 1, 2, 3. So this is a case here the roots are real and imaginary. Roots are real and imaginary. Real and imaginary means roots are complex. Okay, this is the last case. Roots are complex. Okay, here I have used a function sqrt. Sqrt is a built-in function. So in order to use this function, we need to include math.h. So I have include math.h because here I have used sqrt function. Okay, first here I am checking the value, line number 9 to 13. I am verifying the value of a, b, c. If value of a, b is equal to 0, then it will terminate by displaying invalid input. Then it will calculate the discrement value, that is d is equal to b square minus 4ac. After finding the b value, we are verifying the first condition, d greater than 0. If d greater than 0, then roots are real and distinct. And if this condition is false, if the condition in line number 15 is false, it will skip the statements 17, 18, 19, 20 and it move to line number 22. So in line number 22, it verifies one more condition, d is equal to 0. If this condition is true, then it will calculate x1 and x2 is equal to minus b divided by 2a. Okay, this is the condition that is real and equal. If this condition is false, it will skip line number 23 to 27 and it move to else statement. In the else statement, it will calculate the real and imaginary value. Okay, the last case is the roots are complex. It contains two elements, real and imaginary part. So it will display real and imaginary part. Okay, this is the solving the quadratic equation problem.